Good morning everyone. So in this video we are going to discuss about block diagrams. So with the help of the block diagrams we are going to find the transfer function over here. So here also the transfer function is the C of S divided by R of S. So with the help of this block diagram, it will be the block diagram. It will be shows the component in control engineering. So normally with the help of the block diagram we are going to find the transfer function. Okay, and also in the this type of block diagram problems they are going to provide so many blocks that we are going to reduce into the single block. So with that what happens, once if we are giving the input we are getting as a output value. So if so many blacks are there, so if you go and find in the all the blacks the transfer function and find it will become out, it will take some time consumed. Okay, so that it will take time, so that we are going to reduce the block diagrams blocks, we are going to reduce the blocks over here. So normally the block diagram is like this. So in this one, input is R of S, output is the C of S, error signal is the E of S, and G of S is the blocks, and H of S is the one more block. Okay, so here the signal is flows from R of S to C of S is in the forward path, left to right. Okay, so our input to output directly it comes means that is the forward path. Then the H of S is the feedback block, the signal is the B of S, feedback signal is the B of S. Okay, so normally the block diagram is like in this manner. So this is called it a summing point, and this is takeoff point, this is the block. So this we are going to be reduced over here. Okay, so this is the example for the closed loop systems. Okay, and comes into the here some of the rules we have to remember. In the summing point, the signal A is coming over here, B is coming over this side. What is the output signal we are getting is the A plus B signal we are going to get. Then comes into the this type of summing point, A signal is coming, B signal is coming over here, then output is the A minus B. So like same, or some three signal is coming, A and C is the positive sign and B is the negative sign, means the output is the A minus B plus C. So these are all the things you should have to remember over while making the reducing the block diagrams. Okay, then comes into the other thing, what is the forward path? Already I told you forward path is the input from the output, or left to the right, easily you can remember. So if you see here the blocks are there. Okay, so R of S is the input, G1 of S is the uh, block. Okay, so that what is the output? R of S into G1 of S. Okay, output for in this system is the R of S, that is input into the transfer function. So R of S into the G1 of S. So for the next one, input is the R of S, G1 of S, the block is G2 of S, so that output is the R of S, G1 of S into G2 of S. So like the G3 of S, so this will be the input, and what is the output? So output is the R of S, G1 of S, G2 of S into G3 of S is the output over here. Okay, so if it may be so many blocks, what happens? The signal it will goes, find the value, come as output, and again find value, finally it will become as a output. So it will take time. Suppose if it is a single block input, only we are getting output. Okay, so that is the advantages we are getting in the reduction in block diagram. Okay, so here also we are going to find the transfer function C of S by R of S. So what is the transfer function over here? Finally, that is R of S into G1 of S, G2 of S, G3 of S. Okay, that is the okay. So that means what we are going to understand from this one means, if going to find the output, that is going to multiply by R of input into the transfer function or block. Okay, so that is the output value you are going to get over here. Then comes into the direction of flow of signal from output to input is known as feedback path. So actually the signal it will force from right to left, that is the feedback path we are going to say here. So here the signal it comes over here and so goes to again over here. Yeah, with the help of this feedback signal it produces the error signal. Error signal is going to compare the feedback signal onto the reference input, then it's going to provide the error signal. Okay, so this is about the feedback part. Then comes into the block diagrams of closed loop system. So in the block diagram of the closed loop system, one point we should have to remember. So wherever they are going to give the feedback path, the final formula are going to write like C of S by R of S is equal to G of S divided by 1 plus or minus G of S into H of S. Okay, this is the value you have to remember over here. How these values will come, we are going to take in terms of this derivation. Okay, if you see in this figure, R of S is the input value, E of S is the error signal, C of S is the output, G of S is the forward path block, H of S is the feedback block path. Okay, now so in this figure we can write E of S is equal to R of S minus B of S. Am I correct or not? So that is the A signal, B signal, A minus B, like we are written, no, same like E of S is equal to R of S minus B of S. So this is the one first equation. Then comes into the second one, B of S. So this is the B of S. So for B of S I can written for B of S, which is the input, C of S is the input, then block is the H of S. Okay, so that this I am going to write C of S into H of S. Okay, so B of S. So this is I am going to take this as a second equation. Then I am going to write the C of S. So what is the C of S I am going to write? So that is the input into the block. Okay, for C of S, this is the output value, means we are going to find with the help of input into the G of S. Which is the input? E of S is the input, G of S is the block. So G of S into E of S. Here E of S value already we find with the help of first equation. So E of S value you can substitute over here. When substituting, this can become G of S into R of S minus B of S and C of S. So can G of S we are going to multiply inside of this box, and finally we are getting C of S is equal to G of S into R of S minus G of S. So here while multiplying inside B of S, so B of S value already we found, C of S into H of S. So G of S into C of S into H of S. So finally this equation it will become like C of S plus G of S, C of S, H of S is equal to G of S into R of S. But for finally what we are going to find? C of S by R of S. Why? Because of output by input is the transfer function. So which is the output? C of S. So C of S we are going to keep over here, and R of S is the input. Okay, then this equation it comes G of S by 1 plus G of S into H of S. Suppose here they are providing plus symbol, the bottom one it will becomes as a negative sign. Okay, here they are providing minus symbol, here it comes as a plus. So that the common formula we are going to write G of S by 1 plus or minus G of S into H of S. Suppose here the sign they are providing plus or minus, here it will be changing. Here minus means plus, here plus means here minus. So that we should have to remember. Then comes into the rules for some block diagram. So combining the blocks in cascade method. Suppose the blocks are arranged in series or cascade method, means what we are going to do, that means reduction block diagram. So here input is G1, output for this one is G1, G2 is the block, input is G1, G1, G2. Okay, so that this we are going to convert in the single block, means what we will do, A into these two things we are going to multiply. That's it. A into block should be reduct, we are going to do the reduction, so it is coming to G1 into G2. So final output it will be remain same like combining the blocks. So this is the parallel manner the blocks are connected, G1 G2. Okay, so what is the output? Parallel manner connected means we are going to add G1 plus G2. While reduction in blocks, it will be going to add summation of. Then eliminating feedback loop. Just now we have seen the derivation that you can going to write G1 divided by 1 plus or minus G1 H1. So G1 divided by 1 plus or minus G1 into H1. That's it. This is the formula for feedback path. So depends upon the sign over here it will be changing. Then comes into the moving summing point ahead of the block. So whichever point summing point is there, we are moving towards left side. Okay, so right side to left side or ahead of G1 block means this equation it will become. So here B by G1 in the block it will be consist of 1 by G1. So whatever G1 is there, that will becomes in the denominator 1 by G1. So here what is the output value? B. Why? Because of C, the input value, sorry, input value they given as a G, so B. So if you are multiplying these things, automatically you are going to get B only over here, whatever the input is going to give. Okay, so then comes into the other one, moving a summing point beyond, that means after the block. That means A and B is the output, A minus B G1, A G1 minus B G1 is the output value. If you see over here moving outside, what happens? So B into G1 B G1. So whatever the term is there, the same block we are going to add over here. Suppose if you are moving towards after the block, then comes into the next thing, moving takeoff point ahead of a block. So the takeoff point is after the block is placed, this will be moved on left side of the block. That means the block, one more block, whatever the value is provided in the blocks, the same thing we are going to add over there. That's it. Then comes into the moving the block behind the block. Okay, so while moving behind the block, we are going to multiply 1 by G1 in the blocks. So here G1 is there, so that it comes in the denominator 1 by G1. So these are all the rules we should have to remember for to solving the block diagram. Okay, so the next class we are going to discuss about the block diagram problems.